So this is not a talk about augmented reality. I signed up. I was going to give a talk about augmented reality. I'm really fucking sick of talking about augmented reality these days. So sorry, and this is way cooler. So this is about Rust and how it uses its types to become thread safe. And this is not a thing that is special in the compiler. It knows nothing about threads, and we can do this with any concept. In Rust, you achieve inheritance, or not inheritance, but reuse of behaviors through something that's called a trait. For those of you who do a lot of Haskell, it's literally just Haskell type classes. For everyone else, it's kind of like an interface in languages like Java, but a bit more composable and can be added after the fact. And in addition, we have things in Rust called marker traits, which are just traits that have no behavior associated with them, and you only use them to mark a type somehow. So in Rust, there are two traits that are related to thread safety. One is called send, one is called sync. Send means it's safe to send to another thread. Sync means it's safe to share across multiple threads. So this is the function signature. It's a little simplified just because there's some extraneous unrelated details, but this is the function signature for spawning a new thread. And you have to give it a function, and that function needs to be send and static. So static means that it has to be able to outlive the lifetime that you created it in, which in the case of a function means that it has to own everything. It can't have any borrowed data that would go away, no stack allocation, and you can't have shared references. And so send, like I said earlier, is a value that can be safely sent from one thread to another. And this is an automatically implemented trait. So if you have a data structure and everything it's made of is send, then your type is also send. And just about everything in Rust is send by default, except for things that could be used to break sharing rules, like pointers. Now, sync doesn't actually ever get mentioned in the signature of spawning a thread. And so sync is meant to mean that you can safely share it between threads. And what's really cool is that nothing else actually needs to know that sync exists, just because for a shareable type to be send, it has to be sync. And that's just in the implementation of what is marked as send, how it's set up. So a function becomes send in the same way that everything else does. If you were to think of what the data structure of a function is, it has its type is basically just the arguments that it takes and the environment that it captures. And if you were to represent both of those as structures, if you only capture things that are send, then your function just becomes send. So you can only pass a function to the thread spawn function if it only closes over data that is safe to send to another thread. So this is all about sharing, and that's kind of core to the Rust philosophy is making sure that you can only share things that are safe to share. So you cannot, data has exactly one owner in Rust, and you can borrow it or you can transfer ownership to somebody else, but you can't share it by default. If you have multiple shared references to one thing, it's also called an immutable reference sometimes. You can share it with as many people as you want. For it to be mutable, you have to have only exactly one reference to it. You have to have a unique reference. And borrows work really, really well for very simple and straightforward lifetimes, like a single-threaded context, but not so great for complex ones. So there is a type called RC, which is for reference counted, and it looks like this. And you can see here, this is a pointer. Pointers are not send. RC is not send. And for it to be send now, somebody would have to go in and explicitly say, this type is send, and I have made sure that this is safe to use. And RC is not safe to use because it is not atomic in its reference counting. So there's another type. There's another type called ARC, which is atomic reference counted. And its structure looks very similar to that of RC. It's just the implementation that's different. So it wouldn't be send by default, but it has been marked as I am always send if we are send and sync, and that's all we have time for? No, one more minute, okay. So both RC and ARC, though, still don't let you have shared mutable state because they only allow you to have an immutable reference to the data that they own. And so you need a type that is both sync and is able to expose a mutable reference to its data if you want to share across it. And there's only exactly one type that does that in the Rust standard library. That is mutex. So, and this is not special case. You could totally just create a trait foo with no behavior and say this is implemented for everything, and then this only takes foo safe functions. And this could be done in Rust with any concept that you can think of, and it's all just done with clever use of the type system. And so these are already best practices. The compiler isn't like forcing anything new on you. If you're sharing mutable data without a mutex right now, you're probably doing something bad. So this is it just won't let you write a program that's incorrect, and that's really cool.